Well, a system is a set of interacting or interdependent components or elements that form an integrated whole. So key elements also of the model components are stocks, flows, and parameters and variables. We also have interrelationship between elements, and we have, as I mentioned before, boundary conditions. So I'm going to start explaining more in detail what are these elements and what are the main characteristics of these elements. So a system have a structure defined by components, elements, and their composition. Systems have behavior, which involves inputs, processing, and outputs of material, energy, information, or data. So when we define a system will have flows, something that is called flows that affect uh, uh, a variable that we are tracking in the system. We can have, for instance, a system can be, let's say, a lake, like in this side, or can be a balance region in a tank reactor, for instance. So in a lake, we know that we have flows that inputs on the lake and outputs of the lake, and these affect one variable, and that's what we want to model. What is system behavior? Well, later on we will discuss more in detail what is a system behavior, but in general it's about what happens to the variable that we're looking at. So the behavior can be like, is it, if we're talking about volume of water, let's say, we can talk about if the volume of the water oscillates throughout the year, or we can talk about if it has, the behavior is an exponential behavior or a logarithmic behavior that reaches steady state conditions or not, or if the system is behaving with limits, with a constant that limits the growth or the decrease of the volume, for instance, in this case that we're talking about volumes. So systems have interconnectivity. The various parts of a system have functional as well as structural relationships to each other. So there are some independent flows, but there are other flows that will be dependent or will have a relationship with the variable that we're tracking. And then we will understand this more in detail. Systems may have some functions or groups of functions, and we will see now what I'm talking about. So what is an environmental system? An environmental system can be a region having different activities affecting the stock. A stock is an extensive variable in this, and a stock can be a component or energy that is being affected by different activities. In the other side, in the left side, an environmental system can be, for instance, a geographical area where human activities have made an environmental change, and we want to now understand how the system behaves. So in this case, we have an example where we have a dam, and a very famous dam that has affected the human the way of human life in that region by flooding areas that were not like that in the past, as you can see on these two pictures, or that have affected the ecology of the region. There are many things that can happen, or many processes that can occur in one system. These are some examples. For instance, if we're talking about a region, a geographical region, we can have processes that are going on at different scales. So the process that can occur, for instance, or that we can track is our microbial growth, the change of an element like nitrogen. So the processes that are affecting the nitrogen are nitrification and denitrification. The process that can be occurring on the system are population dynamics in population, growth of crops, water transport in unsaturated soil, or pollutant transport in aquifers. So for every process, we have key variables. So in the case of microbial growth, we have biomass, nitrogen content, but we can also have a substrate that is the food for the microbes, or we can have another variable can be oxygen if the process is requires oxygen, let's say. We can have variables for the nitrification and the nitrification process that occurs in natural environments, but also in control environments like such as wastewater treatment plants. We have where the variables that we are tracking are nitrogen compounds, but also the microbial activity, because the microbes are the ones that are driving this nitrification and denitrification processes. The variables for population dynamics are, for instance, the density of eggs, if we're talking about population of a certain animal, the juveniles, larvae, adults, if we're talking about also the animal in particular is an insect, for instance. So for every process we have variables, and we also have a characteristic time. So the scale of how this process is occurring can have different time scales. So crop growth can occur in a time frame of months. The population dynamics can be in a time frame of weeks, but microbial growth can be in a time frame of minutes or hours. So, and even we can even have processes that occur in several years, right? Like transport of pollutant transport in aquifers. And for every process, we also have a mathematical model. So based on the inflows and outflows within the process, we will have a representation of the system through equations. These are examples of these equations that we can have in these processes. For instance, we can have for microbial growth, typically we will have ordinary differential equations. But for instance, for transport of pollutants, not only in aquifers but also in air or in soil, we will have partial differential equations. But this is out of the scope of this course. So in this course, we are going to mainly deal with ordinary differential equations. We also have differential algebraic equations, which are also basically can be an ordinary differential equation, but with another variable that is not implicit on that equation.